The second function we can talk about is the hyperbolic function, or sometimes called the hyperbola. And as we discussed in the last lesson on quadratic function, the general formula for the quadratic for the hyperbolic function is y, which is f at x, which is equals to a x plus p plus q, and these are just constants. So a, p, and q are constants, and then x and y are your variables, right? So you can just try to describe them, what a is and what b is. So in terms of a, let me just do this. A has an effect on the shape, as well as on which quadrants are we actually going to draw our function. So for example, if the value of a is greater than 0, that means it will be positive. You find that our quadratic function is actually going to be in the, it's not our hyperbolic function is actually going to be in the first quadrant as well as the third quadrant. You will see shortly how that happens, right, when we plot them. And then if a is less than 0, that means your a is negative, so maybe it's -1 or it's -4. Your hyperbola is actually going to be in the second as well as in the third quadrant, right? Cool. So the other parameter we can try to define is this q over here, right? So let's say q is our vertical shift. Still the same thing as in the parabola. So this is our vertical shift. And if q is greater than 0, that means q is positive. It means that our hyperbola would have shifted q units up. So it will depend on what value q is. If it's 1, our hyperbola would have shifted 1 unit up. If it's 2, our hyperbola would have shifted 2 units up. I think you see what I mean. And then if q now is less than 0, that means it's negative. It means that our hyperbola would have shifted q units down. So if this value is -2, it means that our hyperbola would have shifted 2 units down. If it's -3, our hyperbola from origin would have shifted 3 units down. The last thing we can talk about is p here. P over here. So p is our horizontal shift, right? So it depends whether how something shifts in the x direction. Remember, v was the vertical shift, how a function shifts up and down in the y-axis. For this one, p, how that function actually shifts in the x axis, right? Cool. So the same thing, if p, I'm lying, it's not q. If p here is positive, or it's greater than 0, meaning that it's positive. What does it mean? It means that our our hyperbolic function would have shifted q units to the left. Q units left. So if, for example, it was x plus 1, our hyperbola will shift 1 unit to the left. If it's x plus 2, our hyperbola will shift 2 units to the left. You'll see this when we plot them, right? And now when p is less than 0, it means that p is negative. It means that that hyperbola would have shifted q units right. So if we have x minus 1, it means that our hyperbola would have shifted 1 unit to the right. If it's x plus 2, x minus 2, our hyperbola would have shifted 2 units to the right. So it's very important for you to understand these things before we can actually try to if we can actually try to plot them. The other important thing about hyperbolic function is a concept of asymptoty. So asymptoty is a line that a curve approaches. So for example, you'll see that if we have so this is our y, this is our x, and we have a graph over here. X, this function here approaches the x, but it never actually touches it. Even here, you see that this graph approaches y, but it never actually touches y. So that line that your curve or your function approaches but never actually touches is called an asymptote. And then how do we find the asymptote of a hyperbolic graph? You'll see why it is relevant to know the asymptote. So to find it, we say, okay, we in a hyperbolic function, we have both a vertical asymptote, asymptote, and it's given by y equals to q. So the value of q here in your graph, if you look at your general formula, will actually give us our vertical asymptote. And then our horizontal asymptote, I'm just gonna write asym is given by x equals to minus p. So whatever value of p is, you're going to put a negative in front of it, and then you find those two asymptotes, right? So I think that's more or less some of the things that you need to know before we actually delve deeper into plotting them. So what I'm gonna do is that we're gonna plot a number of functions, a number of hyperbolic functions, and you will be able to actually see the effects of a on the graph, the effects of p, as well as the effect of q, right? Cool. So let us just do that. So let us say a question said you should plot a hyperbolic graph let me a hyperbolic graph with the following function, which is 1 over x, right? So before we go on plotting it, we can just deduce a number of things. We can conclude a number of things about it. So the first thing we can conclude is that for this function, our a here, we can agree that our a is equals to 1, right? And then there is no p, it means p equals to 0. So there's no horizontal shift, as well as q is also equals to 0. There is also no vertical shift, right? And yes, that's round about it. And then to find our vertical asymptote, so we said our vertical asymptote, let me write vert, is just going to be y equals to q, but we know that q is equals to 0, so it's y equals to 0, meaning that the y-axis will actually serve as our vertical asymptote. And then horizontal, we said it's y equals to negative p, and then we know p is 0, so meaning it's not y, it's x, and meaning that x is equals to 0. So our horizontal, our x-axis will actually serve as the our when x is equal that line when x is equals to 0 will actually serve as our horizontal asymptote, and that line when y is equals to 0 will actually serve as our vertical asymptote, right? Cool. I'm hoping that this is clear. It doesn't look clear from where I'm sitting, but it's fine. Let's continue. So we're trying to plot this function over here. So how can we do that? As we've done with the same thing with the parabolic function, I started first by just drawing a table. You can also use your calculator. There's a way you can do it with your calculator. It's just unfortunate that I don't have a calculator. So you have x and y, right? X are your independent variables, and y is your dependent. So we have -4, -3, let's say -2, -1, 0, 1, 2, 3, 4, right? Cool. So just use your calculator, right? If x is equals to -4, how much is 1? So our 1, if you put it in your calculator, is going to be 0.25. It's going to be 1 over 4 is going to be 0.25, right? This is if x is equals to 3, it means it's going to be 1 over 3, which is 0.3. And then if x is -2, remember I keep forgetting the negatives. There's not enough space. So this is -0.25, -0.3. This one is going to be -0.5. Can put it in a calculator. Then this is going to be -1. And then if x is 0, you can't divide by 0. So meaning it's going to be undefined. Undefined. Remember, you can't. So x cannot be 0. Right? You cannot divide by a 0, right? And then if x is 1, it's just going to be 1. 0.5 if x is 2, 0.3 if x is 3, and then 0.25 if x is 4, right? And let us now try to plot this function, right? So you see at 0, that function is undefined. There's nothing. That is because our asymptote are also at our horizontal asymptote is at x is equals to 0. So that's the line that your function cannot touch, right? That it approaches. So you go about, you just draw your Cartesian plane, right? So we started with -4 this side, say -4, -3, -2, -1, 0 here, and then you have 1, 2, 3, 4. And then on this side, the maximum -1. So we can say this is -1, and here is +1, right? And we try to plot that. Let us try to actually plot that function. So we have -4 and -0.5, right? That's the values that we have, -4 and -0.5. So this maybe will be 0.5, 0.25 would be in the middle. So that point will somewhat be there. Then we have -3 and 0, and 0, what is it? 0.3, right? So -3 and 0.3. 0.3 might be somewhere there, right? And then we have -2 and 0.5. It will be somewhere there. -1 and -1, right? And then at 0, remember, it approaches this side. So your graph will actually look something like this. And as you see, it's in the third quadrant. And we said that if our a is positive, it's in the first as well as the third quadrant. So we also draw the rest of the function on this side, right? So it says to us, so when 1 is 1, when x is 1, y will also be 1. When x is 2, y will be 0.5, maybe 0.5 will be there, right? So that function, that point will be there. When x is 3, it's going to be 0.3. And then when x is 4, it's going to be 0.25. And there is our function, right? You see, it approaches the x-axis, but it never actually reaches it. The same way on this side, it approaches the y-axis, but never touch it. So this side where x is equals to 0 as well as y is equals to 0, that is our vertical and horizontal asymptote, right? So now let us try to draw another function. So let us say then we are asked to plot this graph over here where y equals to a -4 over x. X is there, you see it's your denominator. So it is a hyperbolic function. So we can already deduce from here that a is actually -4. If a is negative, it means our hyperbola is going to be in the second as well as the third quadrant, right? And then p is equals to 0, q is equals to 0 as well. What this means is that our vertical asymptote is just going to be y equals to 0 as well, and our horizontal asymptote is going to be x is equals to 0. It's going to be at x is equals to 0, right? So that the y-axis will serve as our horizontal asymptote, and the x-axis will serve as our vertical asymptote, right? Cool. So let us try to plot this function. The same thing, just draw a what is it? I'm trying to think now. So we're gonna draw a table again quickly. Right, so I've written my independent variables over here. And so when x is -4, it means it's going to be -4 divided by -4 is going to give me +1. When x is -3, it's going to be -4 divided by -3 is going to give me +1, 3. you can just use your calculator. When x is -2, it's going to be -4 divided by -2, which is +2. And then when x is -1, it's going to be -4 divided by -1, which will give me 4, right? When x is 0, you can't divide by 0, so it's undefined, right? There's nothing there. Cool. And then when x is 1, our values of y is just going to be -4 divided by 1, which is -4. The same thing here is going to be -2, -1.3. Can use your calculator, and then finally 1, right? Cool. Is this so it's going to be -1. I don't know why I wrote just +1 there. And then we can just draw the Cartesian plane quickly. So now I've just drawn my graph, my Cartesian plane, right? So now we have when x is -4, y is 1. It's +1. So it's here. Somewhere there. If x is -3, my y is 1.3. So let's see, 1.3 will be somewhere there, perhaps, right? And then that's my, so when x is -2, my value is 2 as well. So I'm still gonna be somewhere perhaps there, right? And when x is -1, my value is going to be -4, right? Cool. And then your function, there's your function. It approaches the y-axis there as well as the x-axis, but it never actually touches it, right? Cool. Same thing, we draw the remainder of the graph, which starts from 1, and so after undefined, you know the other segment is going to be on the other part, on the other quadrant, right? So we have 1 and -4. So we have 1 and -4. So it means that thing is going to be here. So -4, right? And then we have 2 and -2. So 2 and -2 is going to be somewhere there. And then we have 3 and 1.3 somewhere there. And then we have 4 and -1. And then there is your thing, there's your other thing. So remember, we did say that when a is less than 0, so that means that a is negative, your function is your hyperbolic function is going to be in the second quadrant as well as the fourth. But the last one we did, when it was positive, it was in the first and the third. So that is something that you have to be able. So here you see, this is where your graph is undefined, right? And you see it's undefined at that side. So when x is 0, so when x is 0, there's nothing. We don't have a y value. It's undefined. And then you have this segment and this segment, and that forms your graph, right? Let us try to draw another function. So let us say the function that we were asked to plot was y equals to -4 over x plus 1. It is a hyperbola, right? Hope you can see that, right? Cool. So from here we can say that our a is -4. It's negative. It means our hyperbola is going to be in this quadrant as well as this quadrant, right? And then p is 0, right? This means that our vertical asymptote is just gonna, remember, it's the negative of p, meaning it is 0, right? And then q is 1. This means our vertical asymptote, remember, our vertical asymptote is just equals to q, which is equals to 1 plus 1 in this instant. So remember what we said, it means that this graph is shifted 1 unit up, and you'll see when we plot it. So we do the same thing. You're gonna draw your table quickly, and then you just fill in the numbers, right? Try to do it as well. So there we are. So when x is -4, it's going to be -4 over 4 over -4, which is +1, which is going, so +1 plus 1 is going to give us 2, right? And then here you find the value of 2.3, here you find the value of 3, here you find the value of 5, here it's going to be undefined, and then here it's going to just be -3, -1, 0, 3. So make sure you find these values as well, and then 0, right? So I'm just not doing them again one by one because you know how to find them. It's just about substituting the value of x at each point, right? Cool. And when you divide by 0, it's going to give you an error message. Your calculator, meaning you can't possibly divide by 0. So that function is undefined there, right? Cool. So if we draw it quickly, we first draw our asymptote, which is plus 1. So we have 1, 2, 3, 4. So we'll draw our asymptote. You draw it with a dashed line there at 1, positive 1, right? And then it's 0 here, -1, -2, -3, -4. And then for our x-axis of 1, 2, 3, 4, -1, -2, -3, -4, right? Cool. So we said this is the vertical shift. So your thing has shifted 1 unit up. So let us quickly draw it. -2, it coincides with 2. So -4, I'm lying. So when the x is 4, our y is going to be 2. When x is -3, let's say it's over there, our x is going to be 2.3. I'm just estimating here. When x is -2, it's going to be at 3. And then when x is -1, it's going, oh, this actually goes to 5. It's going to be 1, it's going to be there at 5. And you see there is our function, right? Then we can do the same thing again. After undefined, it means that the rest of the graph is on the other quadrant. So 1, -1, and -3. It's going to be there. 2 and -1 gonna be there. 3 and 0,3 is gonna be maybe somewhere there, and then 4 and 0 is going to be there. So there is going to be your function over there. So it's almost like it shifted 1 unit up from origin, right? Cool. So let us try to take a few last examples where we are considering the horizontal shift. So let us consider a graph of, let's see, y equals to 1 over x minus 1, right? So q is equals to 0, meaning our asymptote is y equals to 0, right? We've spoken extensively about how you find that. And then your p equals to -1. It means that your horizontal asymptote will actually be at x is equals to 1. So remember, our asymptote is x equals to negative of p. So the negative of -1 is going to be a positive. And a in this instant is positive, meaning our graphs are going to be, our function is going to be like that in the first as well as the third quadrant. So let us quickly draw a table, fill in those details. So we're starting from -2 to +4. So like I mentioned, we're starting from -2 to 4. So it's not just a matter of filling in those details. So when x is -2, it's going to be 1 over -2, -1. So it's going to be, if you put it in your calculator, you're going to get a value of 0,3. And then for -1, you get 0,5, which is negative, get -1. Here you get undefined. Then if it's 2, you get 1. 0.5 if it's x is 3, and then 0.3 if x is 4. So let us quickly try to plot this function. So we said our, okay, let me write this down. 1, 2, 3, 4, 5, and then we can have maybe -1, -2. Decide all of these are negative, and then we can have 1 there, right? Cool. So if we draw our asymptote, we said our horizontal asymptote will be at x is equals to 1. So x is equals to +1 is going to be there. You're going to draw that vertical asymptote there, and then you try to plot. So let us try to plot it. We have -2 so if our x is -2, our y is -0,3. So maybe it's somewhere there. If x is -1, our y is 0.5. So let's say maybe it's somewhere there. If x is 0, our y is equals to -1, right? And then it's undefined. So look at your function. Your function is going to look like this, right? Then you have your undefined there at 1, and then you move to the other quadrant where you have x is 2. When x is 2, y is 1, right? When x is 3, y is 0.5. Then when x is 4, y is 0.3. Then there is your other function. It never touches this asymptote. And yeah, I'm hoping that through this video you can actually be able to plot different types of graphs, right? So challenge yourself, look for examples in your book, and then you should be able to manage.